All right, let me just explain questions that I feel you may have some question. All right, yeah. So if you have your own question, you can ask me. Yeah. Question number 4. Yeah, let me explain this full binary tree. Yeah, we know complete binary tree, near complete binary tree, but in my class, I didn't mention that full binary tree. Yeah, so here, let me give you that concept. Full, from this name, all right, every internal node, internal node, there is some child node. Every internal node must have both child nodes, left child, right child. That's full, only this condition, all right? Yeah, so let me draw a simple full binary tree. Okay, yeah. This is a simple one, okay? Full. Every internal node must have both child nodes, left, right, both. That's a full, all right? But for this case, yeah, this case, all right, yeah, not full, yeah, not full, because this internal node does not have the right child node, so it's not a full binary tree, okay, yeah, all right, yeah, that's the main difference, okay, do not get confused. Full binary tree, complete binary tree, do not get confused. They're different concepts. Okay. Then, based on this difference, then I may ask you questions about full binary, full and complete. Okay? Yeah. So, yeah, because in the final, I may give you a question, ask you this concept again. All right, yeah, yeah. I may ask you if a full binary tree must be a complete binary tree, or if a complete binary tree must be a full binary tree, things like that. Okay, yeah. Yeah. So you use that explanation. Yeah. Here, let me give you another background information why we need to use this concept for binary tree. Yeah. When we define a new concept, we like to use it to represent something, some idea related to comparisons in our algorithms. Comparisons. We use full binary tree to represent comparisons. Yeah. To model comparisons. Why? When you do comparisons at one node, we will use one node to represent one comparison. When you do one comparison at a node, you have less than, greater or equal to, right? Yeah. Two possibilities. We use less than, A less than B, and B, A, the other one, greater or equal to B. Okay? Yeah. Two cases. We always have these two cases, right? Yeah. It's not, sometimes you have only one case. Yeah. We always have these two cases. That means we always have two child nodes, right? If we need to do one comparison, we always have two possibilities. These two possibilities, we use a full binary tree to describe it. Okay? Yeah. So that's the reason you need this concept, comparison. Yeah, we want to draw a binary tree to tell us how to do comparisons. Yeah. Yeah. All right. Okay. Yeah. So, all right. All right, yeah. So a lot of questions, you need to be familiar with the notes. Yeah, for this one, number 11, you need to be familiar. I explain the detail in the notes, the height, remember. Yeah. How do we fix a heap? Fixing operation. We go from root, going down level by level until we reach the bottom. Each level, we do that. Remember, I wrote a pseudocode, if, 3 if statements. All right, 3 if statements. That's big O of 1, right? Big O of 1 each level. Each level. And how many levels? You need to look at the number of levels. Yeah, level. Multiply bigger of 1. Okay? Yeah. From root to the leaf to the very bottom, how many levels? Yeah. Then you can get the answer easily. All right? Yeah. Yeah, quick sort, yeah. Remember, I have a example, concrete example, that diagram from beginning to end, step by step. You just use that example, run this array, on this array, get that partition, yeah. Yeah, this one, yeah. Yeah, let me explain. Merge sort, 7-element array. How many comparisons do we need for the best case? Yeah. Here, let me use another special example to explain. Let me use 6-element array. Okay? Let me do work on 6-element array and show you how to do the merge. Then you use the same way you do the 7-element array. Yeah. All right. Because here we just consider the best case. So we know this formula for best case to merge 2 array with m element in the first array, n element in the second array. The formula is minimum of m and n. That's the formula we use. Every time when we do a merge, we apply this formula. Okay? All right. Now, let us consider 6-element array. All right. 1, 2, 3, 4, 5, 6-element array. Okay? Yeah. We do splitting. Yeah. In an even way, whenever we have a chance, we split the current array into 2 subarrays as even as possible. Okay? All right. So the first split, we split in this way. Okay? Left subarray, right subarray, each one 3 elements. Yeah. All right. In the left subarray 3, not an even number, we just split as even as possible. Okay? All right. So we split like that. Okay? 2 first subarray, 1 second subarray. Okay? 2, we can still split another time. 1 we just leave there. All right? Similarly, right subarray, the first time split like that, second time split like that. All right? So we cannot split anymore. Let us start to do the merge. When we do the merge, we follow the path, just the reverse of our splitting way. Okay? Yeah. Because think about, when we implement the merge sort, we use recursion. So when we go back, we go exactly the reverse way. Okay? Yeah. Top down, bottom up, reverse way. So let us keeping this mind reverse way. All right? Yeah. First, we do merge these two. Okay? Because last split, so we merge these two. Then we use this representation. How about that? Yeah. This representation, by this formula, minimum of 1 and 1, that is 1, but we also want to know the number of elements, 2. Yeah. 1 comparison, and the result is 2-element array. Because we need this 2 number later. So we need to carry this number, 2-element array. All right. That one, there is no. Okay. All right. Yeah. This side, we also merge 1 comparison, and we get a 2-element array. Okay. All right. That's the first level. Okay. Yeah. First level. Second level. Yeah. We do the merge reverse way. Second level. Okay. Yeah. This time, we merge these 2 subarray. 2 elements first, 1 element second, minimum of 2 numbers, 2 and 1. So we take 1 is the, for best case. Answer is 1. Okay? All right. Yeah, because 2 elements here, 1 element there, minimum of 2 and 1. Okay? Yeah. Here. Minimum of 2 and 1. Okay? So the answer, 1 element and a result, 3 elements array. Yeah. Later we will add up all the comparisons. All right? Yeah. So here we just write the current merge. For current merge, 1 comparison, 3 result, yeah, array. 3 element result array. Similarly here also, we do the merge, these 2 subarray, 1 comparison, 3 element array. All right? All right. Then the last merge, how about that? Last merge, these 2. 3 element, last merge, minimum also 3, right? Yeah, minimum 3. Yeah. By our formula, the last merge, 3 comparison, and result, 6 element array. Okay? All right. Let us add up all the comparisons we have in the whole procedure, all, yeah, add up all, okay, yeah. So total number of comparison, 1, the first level, 1 plus 1, okay. Second level, another 1 plus 1. The last level, plus 3. How about that? 7, the answer. Okay? Yeah, each level, 1 level by level. Okay? Yeah. Let me take that student in. Yeah. How do I get that student? Oh, why I hear something. Oh, Jonathan? Oh, okay. Yeah, because this one I do not need to push that button. Yeah, I know it. All right, let me continue and share the screen again. Yeah. So, Can you do this way on seven element array? Yeah, 6, 7. Yeah. Some place slightly different, but just follow the basic idea. Yeah. You won't miss it. Yeah. If you do this way, you won't miss it. Okay? All right. But here it's a best case. For the worst case, you do the same thing. Yeah. Worst case, the formula is different. M plus n minus 1. Formula is different. But you use this diagram, yeah, with different numbers. Yeah. All right. All right, so that is question number 13. Yeah. I hope you can you can find it. Yeah. And number 14. Yeah. Number 14, yeah, let me explain. This heap, you need to be familiar with the heap structure, binary tree, near complete binary tree. All right, yeah. And minimum number of elements in a heap, height h, and maximum number of elements in a heap of height h. Same height, yeah. So we look at two extremo cases. Two extremo cases. Minimum, maximum. Yeah. What is expression of n plus n in terms of h? Yeah. Yeah. Here, when you draw a heap near complete, yeah. So you need to follow the near complete, the meaning of near complete binary tree. Okay? All right. Yeah. All the levels are full until you get to the last level. The bottom level not necessarily full. Okay? All right. Then, h, we want to have the height h, minimum case. Okay? Yeah. Minimum case. That is, the bottom level only has one node. That's the minimum, right? Yeah. So the height is h. Okay, height including the bottom level. Okay, but to get a minimum number of nodes, you only put one node at the bottom level, lowest level. Okay. The lowest level, only one node. That's minimum. Okay? All right. The maximum, the bottom level is full, right? Yeah. Still the same height. Still the same height. Yeah. But this time, because maximum, you need to occupy all the possible locations in the bottom level. So that is the max case. Okay? Minimum case, maximum case, these two structures. Then you write n in terms of h. Yeah. Number of nodes m you need to write in terms of h. Write n in terms of h. Add these two numbers. That is your answer. How about that? Okay. The first one, you know h, okay? Yeah. If you feel hard to get a relationship between m and h, relationship between m, can you try some numbers? All right? Yeah. 2 levels, 3 levels, 4 level, try some small numbers. Can you see some relationship when you do experiments using small number of levels, okay, to help you figure out the relationship? Based on your observation, you get that relationship. Okay? Similarly here, all right? Yeah. Try some small numbers. 1 level, 2 small. Yeah, try 2 levels, 3 levels, 4 levels. See what's the relationship. Okay? Yeah. After you get those 2 formulas, add up. Yeah. That's this question.
So when you say we express n plus m in terms of h,
H.
are we doing it by the nodes or are we doing it by the height?
Yeah. Right. All right. So you give me a formula. The only variable is h. Other constant. Okay. You can use power of 2. Yeah. 2 to the h, for example, or h squared. Things like that. Yeah. Do not put m or n in your formula. Okay. I don't want to see m and n in the formula. I only want to see h and constant, some constant, several in the formula. Yeah. Yeah. All right. All right. So I hope these hints can help you get, as much as you can in this assignment. Yeah. Yeah. Because the last chance, we don't want to miss our last chance. Okay. Yeah. All right. Yeah. For the minimum value. Yeah. I hope you can get this number 15. Remember, in last class, I did the second smallest, right? Yeah. You use the same way. The smallest, you just try to push. First, it must be a leaf, right? It cannot be internal node. Internal node cannot be the smallest, cannot hold the smallest element. So it must be the leaf. Then the leaf, you want to push that position to the leftmost position. Okay? Try to push. Yeah. Yeah. I hope. Yeah. All right. So let me just draw that diagram again to remind you the second time. Okay? All right. We know these elements take the position from 1 through n. Then, let us look at the leaf block. Yeah. We have a leaves block, this block. Leaves, yeah, not level. Oh. All right, yeah. Leaves block, okay? All right. And we need to know the range for the leaves, right? Yeah. We have the formula +1, okay? Yeah, through n. This block corresponds to the leaves, okay? Yeah. This part. Yeah. Other than that, all internal nodes. Okay, all right. Now, minimum value must be a leaf, right? Must be a leaf. Then, you can use any position in the leaf block to hold minimum, right? But we want to get the smallest possible index, the leftmost position in the block, right? Yeah, so obvious. Okay, yeah. Just a similar idea. The last time in that example, a little harder than this one. Okay, the last time, second smallest. Okay, yes, we need to look at the internal node. Okay, but height 1, you cannot look at height 2 block. Height 1 block. Then you get leftmost position in height 1 block. Yeah, that's a little harder. Yeah. Yeah, that's the previous last class. Yeah. All right. So I think that's pretty much the hints I like to give you in this assignment. Any question? Yeah. If you have further questions, you can ask me. Yeah.
15 should not be written in terms of age, like the question before.
Right. Good. Yeah. Actually, you do not see H here, right? Yeah. Yeah. In my statement, you do not see H. Yeah. That means you should not use H. In my statement, you see the visible variable expression n, so you write it in terms of n variable. Yeah. Okay. Yeah, that's the usual way we do. Yeah. If the variable is not given in the statement, question statement, then usually you should not use it. Yeah. Only when there is some special complicated situation, then it's possible. Yeah. You define some variable, the special meaning, then you use your formula, use that variable. That is okay. Yeah. Yeah. All right. Yeah. So that's the homework assignment number 2. I hope you can get much better in this assignment. Yeah. Yeah. All the remaining things I didn't explain coming from notes. Okay? If you find the right position, you can find those items. Yeah. Yeah. Just from notes. Okay? All right. Then, before I move to example part, yeah, our relatively hard example questions, let me explain one question in our current quiz number 5, because one student asked me that. All right? One student asked me that question. So I like to explain here. Okay? Yeah. Let me go there. Okay? Let me go to that question. And yeah. Because the due date is tomorrow, right? Yeah. Some of you may already submit, but for those who have not submit quiz number 5, yeah, let me just talk about that question. Okay? If you have a chance, still you haven't submitted, you have a chance to do it correctly. Yeah. All right. The quiz, yeah, here. All right, question number 5. Only one question. Well, I didn't see that question. Just a minute. Yeah, let me look at closely. Yeah. Oh, that's not that question. Not in the quiz. Yeah. Let me look at the homework assignment. Yeah, probably still in the homework assignment. Yeah. Huh? Hey, that's strange, but because I remember one student asked me that question. Oh, let me double check. Oh, that's probably quiz 4. Yeah, probably not in the new quiz. Yeah. Anyway, yeah, I'll talk about similar questions in the examples. Probably you remember that. The question is, I ask, if it is a good idea to use the median as the pivot element. When we do the partition in quicksort, is it a good idea to use the median as the pivot element? Yeah, that probably quiz number 4 question. Yeah, already completed. Yeah, yeah, but I will answer this question when I work on one special example today. Yeah, I can talk about that. Yeah. All right, so let us start new problem session part B. Last time we did part A. Yeah. I gave 6 questions, but I just did 5 of them. Actually, the last one, the number 6 one, similar to the first one. Yeah. Same type of question, just with different numbers. Yeah. So I think I can skip. Yeah. Yeah. Because the way we do it, if we just replace m by one number by another number, we can find the answer easily. All right? Yeah. So I can skip that question and let us move to part B. Yeah. So I select a few more questions in part B. Yeah. Because they are relatively hard, challenging questions. Yeah. So I like to explain the details in this part. All right. Example number 7 through number 15. Yeah. I added several more. Yeah. So last time, my previous slide, you see number 12. So I add 3 more. All right. So let me give you the idea. How do I plan to use these examples? Yeah. This is a review session. These examples will be used for your final exam. Okay? So that means these examples are important. Okay? Final exam based on these examples. All right? Yeah. Okay. All right. In the final, I will use these examples in 2 different ways. 2 ways. Part A way and part B way. All right? Yeah, we have 2 parts. Okay? Yeah. All right, so let me change the color of, oh, just a minute. Before I start, I need to get my tools ready. Yeah. All right, so I have something I need to get ready. My remote control, yeah, because I need to use the slides. Remote control. Yeah. Somewhere. Yeah, here, remote control first. All right. And, all right, it works. All right. Another thing, yeah, I may need this. Yeah, I also need this. All right, so let us start and change the color of the ink. Yeah, here. All right, yeah, let's start. Yeah. Okay. All right, yeah, this way, okay? All right. All right. Yeah, first let me explain how do I plan to use these examples in two ways. The first way, in part A, I may use some of the examples, and part B. All right. Part A, I typically ask you straightforward questions. Yeah. So what's the straightforward question? All right. So you see the examples I give you. Usually I do not change much. Okay. I just change a number. I do minimum change. Yeah. So that means straightforward, right? If you understand these questions, then you plug in some numbers, you can get an answer easily. All right. So part A, typically I ask you straightforward questions based on these examples. Okay. Yeah. Part B, not straightforward. All right. Yeah. Part B, all right, ask you. You need to do some serious work on top of these examples. All right? Yeah. Non-trivial work, okay? Yeah, yeah. I will explain the non-trivial work. So that part is relatively hard, okay? Yeah. You need to connect, make that connection. The connection is not obvious. The connection, you need to really have some insight. I will give you some example. I will give you some example. Yeah. One example, yeah, let me give you one example here that you did in the midterm. Midterm we did one, right? Midterm we did one. So what's that example? Remember, the midterm we have one example like this. In a given array, remember? Yeah. I draw a diagram like this. Okay? Yeah. I ask you find an element. Find an element with these conditions. Not in top 2 and not the smallest. How about that, right? Not in top 2 and not in the smallest. Okay? Yeah? Yeah. And you need to make connection. Yeah. You need to convert. All right? This question just, you select 4-element group and you want to find second smallest. That's the work you need to do. See? That's what I mean, non-trivial work. Okay? Non-trivial work. All right. Later, I will get to this point another time. Later, I will show you how to find the second smallest element in the array. After that, let me make comments on this question another time. How to find the second smallest element in a general n-element array. After that, then I talk about this idea another time. because you will have a similar question in the final. Similar question in the final. So you need to really understand this example. Okay? All right. Yeah. So let's start. Yeah, we will see this kind of question later. Yeah. Another time. Number 7. Yeah, this is a pretty hard one. Yeah. Let me explain that. In order to find the median of 5-element array, what is the minimum number of comparisons that one needs for the worst case? Yeah, so this one. Yeah. This is a very challenging question. So very good question. So I really want to show you how to solve this problem. Yeah. Elimination method, right? Yeah, we learned that. So it's a good example for the elimination method. Yeah. Here we need to use elimination method. But it's not an obvious way, it's a hidden way. You need to really do some analysis. Then you get to that point to do elimination. But that part I already gave you in one of the homework questions. Homework number 1, not homework number 2. Homework number 1, I already give you that question. You can do the elimination. Okay? Yeah. So if some of you go back to see, so in C, one of our homework 1 questions. Okay, yeah. Later you can go back to see that, yeah, but it's a, when you work on that question, easy step, but if you can find that step, that's not easy. That is not easy. All right. So let's do the work. First, the answer is C. C, 6 comparisons. In order to solve this problem, we need 6 comparisons for the worst case. Yeah. Here, let me just show you how to do it. All right. Let us assume we have these 5 elements. X1, X2, X3, X4, X5. Okay? We can assume they're distinct. Okay? Yeah. All right. Then, now let us do comparison in this way. Okay. X1, X2 in pairs, X3 and X4 in pairs. 2 comparison like that. Okay? Yeah. We can assume the winner, yeah, the smaller one is the winner, okay? Yeah. Smaller. All right, smaller is the winner. So X1, first comparison, X1 is the winner. Second comparison, X3 is the winner. All right? Yeah. Then, another comparison between these 2 winners, and we assume X1 is the winner. Okay? Yeah. Without loss of generality. Yeah. Although this is one of the cases, but we can always get this kind of result. Okay? Yeah, just with different elements. Yeah. So we can make a reasonable assumption like that. Okay? Yeah. Let us mark the number of comparisons we did so far. Comparison 1, comparison 2, comparison 3. Okay? So for this part, yeah, we can call this is a preparation step. All right? Yeah, initial step. Pretty easy. We need 3 comparisons. Okay, yeah. Then the answer is 6. We just need 3 more to find the median. Only 3 more we can use to find the median. Okay, all right. Then we draw a diagram. Yeah. Yeah. Now we want to represent the result of the first 3 comparisons in a straightforward way, so we use a diagram. Yeah, so let us draw the diagram like this. Okay, yeah. X1, smallest, put on top. Okay, all right. X1 less than X3, so X3 below X1. Okay, all right. X3 greater than X4, so X4 below X3. Okay, then how about X2? X2 less than X1, so we write, X2 here. Okay, X2. Okay, so in this way we can see the relationship among these elements in this convenient way. Okay, all right. Yeah. All right, so you see 1, 2, 3, 4, number 5 is missing. Now let us put number 5 in. Now we bring this number 5 element here, and we want to do the comparison, to do insertion, try to put it in the right place, insertion. When we do the insertion here, okay, look at this little small array, x1, x3, x4. This is an ordered array, right? Yeah, it's ordered. Ascending order, ordered array. When we try to insert an element in an ordered array, the best way is compare the one in the middle, right? Binary search. How about that? Compare with the element in the middle. That is the best way. So our comparison number 4, compare x5 with x3. That is our comparison number 4. Okay? Yeah. Comparison number 4, then you will have 2 possible cases. We need to try to get 2 possible cases. Okay? The first case, x1, x3, x4, x2, and x5 less than x3. Okay, the first case. The second case, like that. x1, x2, x3, x5, oh, just a minute, just a minute. Yeah, I do this too fast. I do this too fast. Yeah, just a minute. Yeah, because this way I just get confused with the sorting 5-element array. Yeah. Later I have that question. Sort 5-element array. Then we do this way. All right. Yeah, I got confused. Yeah. So the way we use elimination method. All right. Yeah, let me just go to elimination method. All right. All right, let's go to this place, still this place. All right, now let us do elimination. Which element cannot be the median, so we eliminate it, right? Then we can simplify, yeah, we can simplify. Which element cannot be the which element cannot be the median? All right, that question. That's the question in our homework, one of our homework question. Okay, C, that question, x1 cannot be the median. Okay, the answer, x1 cannot be the median. Okay, because you can see x1 is smaller than at least three elements, right? Can median smaller than at least three elements? Median cannot be smaller than three elements, right? Yeah. Think about the median. The median, so if we draw a diagram, 5-element array, this is median. Median can only be smaller than 2 elements. All right? Greater than 2 elements, smaller than 2, but x1 smaller than 3 elements. How can that be the median? So x1 can be eliminated. Okay? All right. After elimination, after x1 is eliminated, we have x2, x3, x4, and x5. Okay? All right. We have 4 elements in the remaining array. Yeah. 4 elements. All right. Then the median of the original array is the second smallest in the current array, right? All right. So the median in the original equals second smallest. Median in the original, second smallest current. How about that? After we remove x1, the old median becomes new second smallest. How about that? Okay? Yeah? x1 occupies one position. That position is gone, so the old median becomes second smallest. All right? Yeah. Now, find the second smallest element in 4-element array, but this comparison, we do not need to do this. We already know x3 less than x4, so we do not need to do this comparison. Okay? All right. Let us do comparison number 4, this is comparison number 4, x2 and x5. Okay? Yeah. x2 and x5. Yeah. We can assume x2 is smaller. Okay? Yeah. Yeah. All right. Then compare x2 and x3. Yeah. We can assume x3 is smaller. All right? Yeah. So x3 after, yeah, that's comparison number 5. Okay? Yeah. Comparison number 5. x3 is smaller. Okay? Then x3 is the smallest. So we should not consider x3. All right. Then second smallest. Okay? Now second smallest. Second smallest smaller than x3. In the remaining 3 elements, x4, x2, x4, x5, it is the largest. So it is, it is greater than x3. Yeah, x3 is smallest, in the current array, x3 is smallest. All right? In the remaining 3 elements, x2, x4, x5, we want to find the smallest among 3. Remaining 3 elements. All right. All right. It cannot be 4. x4 less than x3. It can be 4. It cannot be 5. Okay. 5 less than x2, and x2 less than x3. So 5 cannot be the greatest among the 3. Right. not greatest, smallest. Yeah, I always confuse greatest, smallest. All right. Yeah. Can I be the smallest? All right. Yeah. All right. So x5 can be excluded. So the last comparison is x2, x4, the smallest one. That's comparison number 6. Okay? Yeah. That's how we find the median of 5-element array. Yeah. Pretty hard. Yeah. But you just know the main idea, elimination method. After 3 preparation comparisons, we get this diagram and we can eliminate x1 from the consideration. All right. Then we need to see this fact. Old median becomes new second smallest. All right. Now we try to find the second smallest. But we already know x3 less than x4, so we don't need a comparison between these 2 elements. Okay? So we compare x2 and x5. Yeah, we can assume one smaller than the other. Yeah. Then we need to do another comparison to find the smallest. That smallest can be excluded. Yeah. We want the second smallest. Okay? So in the remaining 3 elements, we want to find the smallest. Yeah. All right. But x5 is not the smallest. Okay? So we can exclude x5 another time. In the last 2 elements, x2 and x4, we want to find the smallest. All right? Yeah. So smaller 1, that is the answer. Okay? This last one. So elimination, yeah, at the end, our elimination order. Okay? Elimination order. How do we do the elimination? The first time we eliminate x1, okay, from the consideration. Okay? Second time we eliminate x3 from the consideration. Yeah, because that's the smallest. The third time we eliminate x5 from the consideration. Okay? Yeah. So only x2 and x4 left. We do one comparison, the smaller one will be the answer. So you can see how useful the elimination method is. Yeah. So this example is a good example for elimination method. Okay? Yeah. So after you understand this example completely, yeah, then I may modify this example in some way. Yeah. At this time, I do not know how do I modify it. So when I work on this example, then I try to come up with some interesting way. Yeah. In my view, an interesting way, I make some modification, then I make that question. But you need to make connection. Okay? This is your background. So this example, this solution is your background. Okay? Yeah. So you have this as your background. Yeah, you know, the current question is derived from this old example. Yeah. So you try to, how do you figure out with this background information? All right. Yeah. Then after this one, then I can answer one of the quiz 4 question. Yeah, I just talked about quiz 4 question. That is median as pivot. If it's a good idea or not. Okay? The answer is no. answer is no. It's not a good idea. All right. Yeah. At this point, we have enough information. Yeah. No, it's not a good idea as a pivot. Yeah. Look at how much work you need to do to find the median. Okay, a lot of work, right? A lot of work. All right. Yeah. This example just find a median of 5-element array. Later, I will show you another example. Sort 5-element array with 7 comparisons. Just one more than the median. Find median, we need to use 6 comparisons. To sort the whole array, we need just 7. One more, a 5-element array. So you can see, that means find a median, how much work you need to do. Okay, yeah. Then in the general array, find a median, you need to do a lot of work. That work is not free, right? That work is not free. Okay? Yeah. A lot of time. So the general case, general median, definitely it's cheaper than sorting. It's cheaper than sorting. But in this class, I do not have time to talk about big O of n. You can find a median for the general case using big O of n. Linear time. Some constant multiply n, problem size n. Some constant number. Okay? Yeah. Better than sorting n log n. Sorting n log n. Better than n log n. Yeah. But still, pretty expensive. When you do partition, you don't want to find the median, use big O of n to find the median, then use it as a pivot. Because our partition is big O of n. You find the median already harder than the partition step. More costly than the partition step. Okay. Finding the median is costly than the partition step. Why you spend that much cost? Right? So that's why that answer is no. Don't spend too much time find the median. You would rather pick the random element as the pivot. Then run partitioning. Run partitioning is faster than finding the median. Much faster than finding the median. Partitioning. Okay? Yeah. Very fast. So never do in that way. Okay? Never do in that way. Yeah. All right. So that is this question. Next one. Yeah, this one. Yeah. Last time we did a similar one. Yeah, but here I may like to talk about these questions another time. When we merge 3 sorted array with A, B, C elements respectively using standard merge step, it is not A less than B less than C. What is the minimum number comparison for the best case? For the best case. Okay. Yeah. All right. And here, multiple choice solution. Yeah. Multiple choice. Okay. Yeah. Yeah. So here, because we only consider we merge three sort ordered array. So that number is 3. 3 arrays. Yeah. So the number of combinations, it's a small number. How about we go through all the possibilities? Okay? Then I think, only 3 possibilities, right? Yeah. Yeah. So we can do this way, okay? Yeah. Merge A array and B array. Best case, minimum of A and B, that is A. And the result, A plus B. Okay? Yeah. All right. After that, yeah. So method number 1. Okay? Method number 1. All right. After that, we merge C array and A plus B array. Minimum of C and A plus B. But we don't know which one's smaller, right? Do you know C smaller and A plus B smaller? Minimum of those two numbers. Okay? Yeah, look at that. Yeah. So the answer is this, minimum of C and A plus B. How do you know which one is smaller? Is C smaller or A plus B smaller? Okay? Yeah? Yeah. Yeah. So in that way, the answer, method 1, the answer, total number of comparison, A plus minimum of C, A plus B. Okay? Yeah, A plus that number. Okay? Yeah. All right. So that's the first method. Yeah. Let us leave there. Okay? Let us leave there. Second method. Because we want to try several cases, then we can do comparison. Okay? So that's method number 1. Method number 2, merge B array and C array. How about that first? Okay? Yeah. The answer, minimum of B and C, that is B. Okay? Then the number of elements, B plus C. Okay? Yeah. Then, after that, merge A array, yeah. A array and B plus C array, okay? Minimum of A and B plus C, we know A is the smallest, okay? Yeah, A is the smallest. Now the answer, A plus B, right? See, the answer is A plus B, A plus B. Okay? A plus minimum of C and A plus B, yeah. So higher than this one, okay? Higher than this one. This one, A and B, sum of two smaller numbers, that should be the best one, okay? Yeah. You look at the 4 multiple choices, we can get A case, and that is the smallest number. How about that? How about that? Yeah? See? Yeah. So after we work these 2 different ways, although there is the third way, but we don't need to work. Yeah, because even you work the third way, you can never beat this way. A plus B. A the smallest number, B second smallest number. How can you beat this sum? Nobody can beat this sum. Okay? Sum of 2 smallest numbers. How can you beat that? Right? So we do not need to work the third method because we cannot beat that. Okay? After we get the best possible number, nobody can beat that, right? Among the 4 options, this is already the smallest. How can you beat that, right? Yeah, you look at the 4 options, smallest number, we get that. Okay, yeah. So we don't try to beat the best one. Okay, yeah. So in that way, you can get an answer. All right, yeah. It's already break time. Yeah, past the, I will let us start at the 2:35.